welcome to my presentation about the properties of the periodic table. So today we're going to be starting with group 1, which are the alkali metals. They have some very interesting properties, including their high reactivity, and their reactivity increases as their period increases. That means that as you move down on this picture provided here, you move down the period, these will get more and more reactive. But there is a little weird thing. Cesium is actually more reactive with francium, so just that one little mix up there. But otherwise, they increase reactivity as the period increases. They all have a silvery color. They're very soft metal, so they can be cut with a knife. Their melting and boiling point decreases by increasing the period. So as you go down, the melting and boiling point decreases. When they react with water, they make a base, hence the name alkali metals. Alkali as in a base. You see, it kind of makes sense. They are stored in kerosene due to their high reactivity. So kerosene is a material, and these are put in there because they are very reactive, as we said earlier. And the reason they're very reactive actually is because they only have one outer shell electron. So it's filling the s1 orbital. So it just has that one electron. It's going to be very, very reactive. Next up, we have group 2. Sorry, just clicked twice. We have group 2 alkali earth metals. So they have some interesting properties, including they're harder and denser than group 1. So they're not as soft. As we know, group 1 was very soft. You could cut it with a knife. You can't do that with group 2. And they are less reactive because, as I said earlier, alkali metals fill the s1 orbital. This is the s2. And as we know, the s orbital can only fill 2 electrons. So this is a full orbital. So it's not going to be very reactive. They have a higher melting and boiling point when compared to group 1 because, as we said earlier, they're harder and denser metals than group 1. And just like group 1, when they react with water, they produce a base. That's why they're so called alkali earth metals. Next, we're going on to group 3 to 4. Now, the placement within the periodic table for lanthanoids and actinoids are kind of weird. They're on the bottom of the periodic table, but they are still elements nonetheless, and they have a silvery color. They're soft and can be cut with a knife, much like alkali metals. Lanthanides can corrode or become brittle if they are contaminated with other metals or nonmetals. Keep in mind, they will not corrode or become brittle or break down when they are in contact with metalloids. The first lanthanoid is cerium and not lanthanium. So this is very interesting because you would think lanthanium, that sounds like lanthanoids, right? So it must be one, but it is not. In fact, it is the element right after. Cerium is the first one. But interestingly, lanthanium is still here in the periodic table along with the other ones. And so is actinium in the actinoids, which is the next group in the periodic table. This is a period lower. That was period 6. Now we're in period 7 of the periodic table, and the first actinoid is thorium, not actinium. So the same repeats as we saw last time. Actinium sounds like actinoid, but it's actually not one. They're all radioactive. All actinoids are radioactive, and they're highly electropositive. Now, what does that mean? So electropositive means that they really want to lose electrons and become a positive element, a positive ion. The metals tarnish readily in air. So tarnish means that they lose their shininess, so they become they have less luster when they are in air. They are usually soft metals, much like lanthanoids and alkali metals. Group 3 to 12 is one of the biggest parts of the periodic table, and these are the transitional metals, highlighted below in red. And they have some interesting properties, including they are very good conductors of electricity. They have high luster, which, as I said earlier, means that they are very shiny. They are usually less reactive than alkali and alkali earth metals since they are filling up the d orbitals. Some, like gold, this is a really interesting property, are so unreactive that they exist in nature as free elements. So what does that mean? So basically, imagine this. You're going into a gold mine, and you're mining gold. We've all seen this. Like, it's like a bunch of rocks that are many elements together, and then there's gold. And why is gold separated? Well, it's because they're very unreactive, and that means that they don't want to bond with anything else, they just want to bond with other gold atoms. Next, you have group 17 halogens. These are one of the most reactive groups. They are the most reactive nonmetals, in fact. They react vigorously with most metals to form salts, so they become ionic compounds. Astatine, these are some fun facts about some of the elements in halogens. So astatine is actually an artificial element. Fluorine and chlorine are gases at room temperature. As you can see here, they're red, that means they're gases. Bromine is blue, that means it's a liquid, which is pretty interesting. And another fun fact about bromine, it's actually a reddish color, and iodine is a purplish color. Group 18 are the noble gases, and as we all know, they are very non-reactive due to their last p orbitals being filled up. They are colorless, they're not flammable, and they do not have any odor or smell. Thanks for watching, I'll see you all in the next one.